On to the next one. We've got a basketball player jumping and is in the air for 0.8 seconds. How high did the basketball player jump? Before we get into this problem, I want to go through the importance of just sketching it out again. So if we look at this basketball player, they're going to jump into the air, right? Roughly along this path. So it's a parabola. He's going to go up for a little while and then they're going to come back down, right? In the equal time. So we're only looking for how high do they go. So we can cut this parabola in half and only look at one half. The half that I'm going to use is going to be this back half, their journey on the way back down. Because I know they're fighting acceleration on the way back up. They're slowing, and then they stop right here. So I can set my velocity right here at the top to equal 0. And then we're in free fall and acceleration. Now the thing we have to notice is that even though we're given 0.8 seconds, the time that we are going to use is actually 0.4 seconds. Because it's half the time, we're only looking at half of the problem. So with that being said, we know the time is 0.4 seconds. And this person is experiencing free fall. The only force acting on them is gravity, so that means our acceleration is going to be 10 meters per second squared. The unknown variable, how high, we're looking for that height. So normally we would use x, right? Because we've always been looking at distances, but in this case this person is getting height. So we're really looking at the y-axis. So instead of x, we'll use y. It means the same thing, and you can use x, absolutely. Let's see. Next, what equation do we know that can give us this? Well, we have a velocity that is 0, so we can use the shortcut method of the displacement equation, which is just going to be y equals 1/2 at squared. And then substituting in there, we get half of 10, which is 5 times 0.4 squared, which is going to be 0.1 second. Some kind of issue there. And then when you multiply those two things out, 5 times 0.16, you're going to get the y equals 0.8. Don't forget your units. Does that make sense? Can a person jump a little bit less than a meter, 1 meter being 39 inches? Yes, that seems reasonable for a basketball player. Next, we have an object traveling on a straight line path, so its position is given as a function of time by the graph as shown. So we're given a graph, and the very first thing you need to do when looking at your graph is read your axis and the units associated. What is the average acceleration of the object during the interval between this 3 and 7? So we've got a bend in a position versus time graph. That means we know acceleration is happening because our velocity is changing. So let's see what we've got here. With our guess, what information are we given? We're given this graph, so we have to pull information off of it. This looks like it's going to be our initial velocity here, this thing right here. Erase, please. Erase. Thank you. So that initial velocity, the slope of this is going to be our initial velocity. Looks like we're going from 45 down to 30, so negative 15 divided by 3. So our initial velocity is going to be negative 5 meters per second. Our ending velocity, this velocity over here, is going to be this rise, which is going from 50 to wherever, 80. So it goes up 30, and that took 2 seconds, so 30 divided by 2. Our final velocity is going to be 15 meters per second. And we know the time interval between here and here is 1, 2, 3, 4 seconds. What don't we know? What is the question asking us for? It's asking us for acceleration. An equation that's going to tie all 4 of these variables together is going to be that first equation, the VF equals V naught plus AT. So we can now substitute, and I'll do this the more popular way. For students, I think it's more popular because it just reminds you of algebra class. And you have good memories of algebra class, so you prefer to do it this way, where you plug in the numbers and then solve for your variable. But I prefer to manipulate the equation to get the variable we're looking for all by itself. So we're going to add 5 to each side, and we'll see this is going to equal 20 on the one side, and then equals a times 4, divide by 4 from each side, and we're going to get a equals 5. Don't forget your units, meters per second squared. The correct units, not the fake ones or the wrong ones. Alright, I'll finish up in the next video.